In the Animation and Graphics chapter, you'll learn how to use these capabilities to add interest to your apps. In this lesson, I'll give you an overview of animation and graphics capabilities. The Android framework provides two animation systems: property animation, which was introduced in Android 3.0, and view animation. Both animation systems are viable options, but the property animation system is the preferred method to use. It's more flexible and provides more features. Property animation lets you animate properties of any object, including ones that aren't rendered on the screen. View animation is the older system and can only be used for views. It's relatively easy to set up and offers enough capabilities to meet many applications' needs. In addition to these two systems, you can utilize drawable graphics, such as canvas capabilities, which allows you to load and create drawable resources and display them one frame after another. The developer's website has a large set of sections on animation and graphics in the API guides. And there's also a good training group on building apps with graphics and animation. That's in the training section. In this chapter, we're going to look at some code from the API Demos app. So let's look at the animation and graphics demos listed in the worksheet. There's a group of a dozen demos in the animation primary group. And let's take a look at the kinds of things animation can do in the API Demos app. In the main screen of the Demos app, we'll click Animation, and we'll go through these one by one. Bouncing balls we've already looked at. It animates the background color as well as movement of a ball when you click on the screen. Cloning uses the clone method of the object class to create multiple copies of the ball object and animates them when you click the Run button. Custom Evaluator uses the canvas capability to draw the animation when you click the Play button. Default Layout Animation changes the layout by adding buttons when you click the Add button. Events listens for button presses to change the animation. Play runs the animation. Play Cancel stops the animation. And Play End moves the animation to its endpoint. Hide Show Animations uses checkboxes and a button to demonstrate object additions and deletions. Clicking on the objects removes them. Clicking Show Buttons makes them reappear. Clicking Custom Animations adds a flip to the button removal. If I click Show Buttons, the buttons reappear. Layout Animations provides checkboxes for changing the animation on adding buttons. As I change the checkboxes, you can see the animation change. Loading demonstrates animation using animator objects loaded from XML when the button is clicked. Multiple Properties demonstrates animating multiple properties of the object. Reversing demonstrates creating a reverse of an animation. So when I click Reverse, the animated ball moves back up. Seeking gives you the ability to use a slider to control the animation. And finally, Flip View flips the list from English to French when we click the Flip button. Now let's look at the graphics demos in the worksheet. There are about 50 graphics demos, quite a large number. And this includes a sizable secondary group of OpenGLES demos, which is a graphics capability designed for embedded systems such as those on mobile devices. Let's go through a sampling of the graphics demos in the emulator to give you an idea of what these capabilities can do. From the main demo screen, click on Graphics. And let's look at the Arcs demo, which creates simple shapes in real time. Let's look at the Finger Paint demo, which allows you to draw on the screen. In the OpenGLES group, let's try the cube. which is a demo of a moving Rubik's Cube. Pretty cool. And the translucent GL surface view creates a couple of rotating cubes interacting with each other with a transparent background. And that's just a small sample of graphics capabilities. And I encourage you to look at the graphics demos on your own to get a fuller idea of what they can do. And that's our lesson on an overview of animation and graphics. Now let's move on to the next lesson to look at some of the code for creating these images. In this lesson, you'll learn how to use Android property animation capabilities. The property animation system allows you to animate almost anything. You can define an animation to change any object property over time, regardless of whether it draws to the screen or not. A property animation changes a property's value over a specified length of time. To animate something, you specify the object property that you want to animate, such as an object's position on the screen, how long you want to animate it for, and the values you want to animate between. The property animation system lets you define the characteristics of an animation, such as duration, repeat count, property change characteristics, and frame refresh rate. In the API Demos worksheet, there are a number of animation demos in that primary group. We're going to use the Flip View demo in line 17 to explore using property animation. It has a Java file name of List Flipper. So let's start it in the emulator by clicking Animation, View Flip. When we click the Flip button, it flips from English to French and back again. Let's open the Java code in Eclipse. In the animation source folder, we'll open List Flipper. In line 42, we have the activity class List Flipper declared. In line 44, a variable for the duration in milliseconds of the animation is declared at 1500 milliseconds, which means the animation will last a second and a half. In line 45, a seek bar is declared, but it looks like there was an intention to use a seek bar as part of the animation, but it was never implemented in the demo, so we're going to ignore that. In lines 47 through 61, strings for the English and French words for the arrays to be flipped are declared. In lines 64 and 65, list views for the English and French lists are declared, and you might want to review our lesson on lists for background on list views. In line 69 through 92, we have the onCreate method for the activity. And within that, in line 71, we have the setContentView method that's using the rotating list layout. So in layouts, we'll look for the rotating list. And in line 17, a linear layout is declared. In lines 21 through 25, a flip button is defined. In lines 26 through 36, two list views are declared, one for the English list and one for the French list. In line 36, the French list is set to visibility gone, so initially the English language version of the list is visible. Now back to the List Flipper Java code. In lines 73 and 74, list view variables are set up for English and French views in the layout. In lines 77 through 81, array adapters are defined using the simple list item 1 format for each string list of words. In lines 83 and 84, we set the adapters to their respective views in the layout. In 85, we set the degrees that the view is rotated around the vertical axis through the pivot point. Increasing values result in a counterclockwise rotation from the viewpoint of looking down on the y-axis. Lines 87 through 92 define a listener for the button and execute the flip it method defined below when the button is clicked. The flip it method is referenced here, and we'll see it below in a moment. Lines 95 and 96 set up interpolators for acceleration and deceleration of movement, and an interpolator is used to define the rate of change of an animation. In lines 97 through 123, we have the flip it method that does the actual flipping of the lists, and as you recall, this method's executed when the flip button is pressed. In lines 98 and 99, we define a visible and invisible list view used internally in the method. Lines 100 through 106, there's a test to see which view is not visible in the internal list view variables. Visible list and invisible list are set accordingly. Let me expand this window out so we can get a better view of the code as we continue. In line 107, an object animator is defined for the visible to invisible rotation. The property to animate is specified as rotation Y. In 108, the duration of this animator is set to 500 milliseconds. In 109, the interpolator for this animation is set to accelerator. In lines 110 through 113, an object animator is defined with settings for the invisible to visible rotation. In lines 115 to 120, a listener is set up to respond to the end of the flip animation. And when it's activated, the visibility status of the lists is switched, visible to invisible and invisible to visible. And finally, down in 122, the flip is started. Now that's our lesson on property animation. It's a very flexible set of capabilities that can add interest to your apps. In this lesson, you'll learn how to use Android view animation capabilities. View animation offers a simpler approach than property animation for animating views. I think the best way to understand view animation is through an example, so let's get straight to it. In the API Demos worksheet, there's a secondary group of animation demos here inside the primary views group. And we're going to use the push demo in line 175, and it has the Java file name animation2. So let's start it up in the emulator by clicking Views, then Animation, and Push. Notice that the animation starts right away. We see this text up on top changing. As we click under Select an Animation, we get a drop-down list, and we can select Push Up, which is what it's doing right now. Push to the left, you see that changed the animation where the text is sliding off to the left. Crossfade, where one line fades into another. And hyperspace, which is a combination of stretching and turning. And now let's open the Java code in Eclipse. In the Views source folder, we'll open Animation 2. In line 33, we have a declaration of the Animation 2 class, which extends activity and implements the adapter view on item selected listener. And this is an interface definition that has a callback to be invoked when an item in this view has been selected. In lines 37 through 50, we have the onCreate method for the activity. In line 39, the setContentView method uses the animation2 layout to initialize the screen. So let's open that. And let's expand this window to get a better view at our code. So in the layout, in lines 17 through 21, we have the declaration of a linear layout. In lines 23 through 27, a view flipper is defined. And this is a simple view animator that'll animate between two or more views that have been added to it. Only one child is shown at a time. Using the flip interval in line 27, it automatically flips between each child at a regular interval. The child views are down here in lines 28 through 51, and each one uses a different text string. So let's open the string resource file. We can take a look at those strings. So if I sort on them, and we look for the animation text strings, which are here, click on those. And if you look off to the right here in the value, you'll see the value change. Freedom is nothing else but a chance to be better. Albert Camus. So now back in the layout, in lines 54 through 59, we have the instructions text. Shows up here. And in lines 61 through 64, the spinner. Now back in the Java code. In lines 41 and 42, a view flipper variable is established and started flipping through the text strings we looked at in the strings resources. In lines 44 through 49, a spinner is set up. In line 46, the simple spinner item format for each item is specified, as is the array contents using the mstrings array defined below in lines 85 and 86. In lines 52 through 80, the onItemSelected method is defined, and this is the method that's called when an item in the spinner is selected as a result of the interface onItemSelectedListener. Based on the item selected by the app user, one of these cases is executed. Each case, for example, starting in line 55, for this case, case 0, sets the in and out animation in the flipper using the animation utility loadAnimation. In line 57, let's look at the push up in animation. So we'll open that. It's here, push up in XML. In line 17, it uses the set element to define a group of characteristics. In line 18, the translation characteristics are defined. From Y delta defines the change in the Y coordinate to apply to the start of the animation. To Y delta defines the change in the Y coordinate to apply at the end of the animation. Duration defines the length of the animation in milliseconds, in this case 300 milliseconds, about a third of a second. In line 19, the alpha or transparency characteristics are defined. 1 is fully opaque and 0 is fully transparent. From alpha is the starting point, to alpha is the ending point, and the duration is the length in milliseconds, also 300. That's our lesson on view animations, and they're a relatively easy way to implement some good-looking visual gymnastics. In this lesson, you'll learn how to use Android canvas graphics capabilities. I'll give you a look at the basics of how to draw a bitmap canvas graphic. If you're going to be developing applications like games, this will give you a start and point you in the right direction. There are also a number of sections on the developer's website that you can consult. There's this page on Canvas and Drawables, and there are pages on OpenGL and hardware acceleration. And there's also in the training group a section on building apps with graphics and animation. In the API demos worksheet, there's a large primary group of graphics demos, and I've picked a fairly simple one to demonstrate Canvas capabilities. It's on line 118 and has a demo name of arcs and a Java file name of arcs. So let's start it up in the emulator by clicking Graphics and Arcs. And it draws a series of arcs finishing as circles, and some are just lines and some are filled, and some start drawing at the edge and some at the center. And now let's open the Java code in Eclipse. In the graphics source folder, we'll open arcs. And let's expand this out so we get a good view of the code. In line 28, the arcs class is defined and extends graphics activity. And note, in line 24, we've imported all the graphics packages. In line 33, the setContentView method is initializing the display using the SampleView class. In lines 36 through 87, the SampleView class is defined. So instead of setting up our screen using XML, we'll be setting it up using code in this class. In lines 37 through 47, a number of variables are defined. In lines 37 and 38, paint variables are defined, and the paint class holds the style and color information about how to draw the geometries, text, and bitmaps. In lines 40 and 41, rectangle variables are defined. The rectf holds 4 float coordinates for a rectangle. The rectangle is represented by coordinates of its 4 edges, left, top, right, and bottom. In lines 52 through 86, the characteristics of the shapes are defined using the paint, rectf, and set methods such as set color. Lines 89 through 92 define the method that will actually draw on our canvas. So this is the guts of where the work is done to actually create the images. In line 91, the draw rectangle or draw rect method is used to draw the rectangular outline around each of our arcs. It uses two parameters, a rectf object and a paint object. In line 92, the draw arc method is used to draw the lines and circles of our arcs. It uses 5 parameters. Oval is used to define the shape and size of the arc. mstart, the start angle in degrees where the arc begins. msweep is the sweep angle in degrees measured clockwise. Use center, if true, includes the center of the oval in the arc. And paint defines the characteristics used to draw the arc. Lines 95 through 115 define the onDraw method. And this is an override that provides access to the canvas onto which the drawing is done. In line 96, the canvas color is set to white. In line 98, the draw arcs method we defined above is used to draw the large image here. In line 101, a loop is set up to draw the 4 smaller images using the draw arcs method invoked in line 102. So it's drawing these 4 here. In lines 105 through 111, the sweep variable is calculated. In line 112, an index is calculated that's used to determine the characteristics of the big image at the top. In line 114, the invalidate method is used, and this causes the system to do another execution of the onDraw method to keep the graphic animation continuing. So that's our lesson on canvas graphics. It's a big topic, but you should now have a starting point for developing more complex images.